All right, so this lesson is going to be from our starting chapter 2. And section 1, you can see the titles up there at the top. Okay, chapter 2, section 1, systems of linear equations with unique solutions. So what this is doing is we're taking more than one equation, so really two or more, and we're trying to solve them together. And really what that looks like is what solution or solutions satisfy all of them at the same time. All right, whether it's one variable, two variables, I should say it's two or more variables as well. So X and Y, Z, we can have other variables, depends if it's a context problem. There's not really a limit on the different types of variables you can have and or the equations you can have. You just have to have two or more variables, two or more equations. So we're first going to look at exactly what we're going to be doing. And what we're going to be doing is we're going to be using something called Gauss-Jordan, or it's called Gauss-Jordan elimination. All right, and in Gauss-Jordan elimination, what you're doing is you're going to use something what we call elementary row operations. So you use elementary row operations to solve systems of equations. All right. Now, what are elementary row operations? So I'm going to show you the three different types of elementary row operations that we'll use. So elementary row operations. And it doesn't have to be in this order. I'm just listing them. The first one is one that we don't use quite often. We will need to use it, and I'll show you at the end of this lesson one example of what it looks like. And the first one is that we interchange any two equations. And I'm also going to add, instead of equations, all right, we're going to say rows. So we interchange any two equations, but we're going to use the word rows as well. And you're going to see why here in a little bit. Another thing we could do is we can multiply an equation. Or again, I'm going to say row by a non-zero number. Oops, sorry. And the last one that we have, so the one of the three, is we can change an equation. Or again, row, by adding it to a multiple of another equation, or we could say row. All right, so our first example, we're going to rewrite the system such that the leading coefficient in the equation is 1. So here's our first example here. And it says that we're going to, we'll break it down in two parts. How about that? Let's go two parts. Let's say, A, we're going to rewrite the system such that the leading coefficient in, we'll be more specific, the first equation is 1. All right, so here's what our system looks like. We have 3x plus 6y minus 12z equal to 24. We have x minus 2y plus 5z equal to 7. And then we also have negative x plus y minus z equal to 10. All right, so here is our system. Now, again, they all look like equations. And what we're trying to do is we're trying to say, all right, so how do we get the leading coefficient in the first equation to be 1? So right here, by using one of our 3 rules that we have for our row operations. So by using one of these 3, we want to rewrite it. Now we could interchange and say, look, we're going to make this one become here because the leading coefficient here is 1. But again, let's not do that because we don't use it very often. So let's look more at 2 or 3. So if we're just changing one equation and we just need a 1 out of that value, the easiest way to do it is by multiplying the row by a non-zero number. So we're going to use the second one here. And so we have to think, what do we multiply 3 by to get 1? And the quick way of saying that is one word. It's the reciprocal. If we multiply 3 by the reciprocal, then it gets 1. That's the definition of what a reciprocal is. The reciprocal of 3 is 1/3. So what we'll do is we will multiply the first row by 1/3. All right, and when we do that, you are taking everything in that first equation and multiplying it by 1/3, or dividing it by 3 if you can put it that way in your head. So 3x times 1/3 just gives you x back. 6y times 1/3 gives you your 2y. And negative 12z times 1/3 gives you minus 4z. Lastly, 24 times 1/3 gives you 8. And then you can see that we are not changing the second or third equation, so they just get rewritten. X minus 2y plus 5z equal to 7. Negative x plus y minus z equal to 10. Here is our system rewritten with the leading coefficient of the first equation to be 1, right? Because right in front of this x, there's a 1 there. That's by using elementary row operations. Now, the next one, part B, we'll call it part B here. Let's rewrite. So the coefficient in the second and third equation are 0. And I could even say right here, we could call this the leading coefficient. That way you know we're talking about what we're basically saying is that we want our values in front of the x's to go away. So what we look at is we look at what we have started with. So I'm just going to move this over and copy this. What we're going to do is we have to figure out a way of making this value here be 0 because we want this to go away. Same thing, we want this to be 0, so we want this to go away. Now, in our steps, our elementary row operations, not saying steps is not an order we do this, but we can't interchange any equations because there's nothing with a 0 coefficient out front. Next thing is multiply an equation by a non-zero number. we can't necessarily do this because the only way to make 1 to be 0 or any number to be 0 and you're multiplying is to multiply by a 0. And it says it has to be a non-zero number, which leads us to this last one we can do. We're going to change an equation by adding it to a multiple of another equation. So by rule of thumb, what we like to do is we like to use the coefficient and where we already have 1 at. So for instance, this one right here. We already have the first equation, it's not going to change. So we want to multiply that first equation by a value and then add it to another equation to make what we want to happen. So right here, if we take this right here, this 1, and we want to make this 1, well, I don't really need to multiply this 1 by anything because I want this is already 1. I want these to be opposites. Right now they're the same. So what I mean by opposite, I mean the same absolute value number, so both being 1, but 1 to be negative and 1 to be positive. So I'm actually going to take and multiply this entire equation by -1. And when I do that, I will get a -1 here. And with a 1 here, when I add the two together, it becomes 0. So for instance, we'd write something like this. We would say we're going to multiply the first row by -1, then add to second row. All right, that's the first thing we're going to do. So we're not changing the first row at all. The first row stays exactly the same. So I'm just going to rewrite it. So when I look at this row here, I'm multiplying everything in there by -1. That basically is telling us that all of the values are going to change from positive to negative. And if they're negative, they're going to change from negative to positive. So that means this is now -1. When I add these two together, I get 0. So I don't have to put anything. 0 is where it's at. This now, instead of being positive, this becomes negative. So I have -2 plus -2. That gives us -4y. Next, I multiply this by -1. So I get a +4, right? So +4 plus 5 gives me +9. So plus 9z. And then I'm multiplying this by a negative. So -8 plus 7 gives us -1. So that's what I've done. I've transformed that second equation into what we have written. Now, next thing. Now we have to look at our last equation. Now we don't necessarily, if you look at this, here's 1, this is -1. Well, they already exactly what we want it to be, so we don't have to multiply this by anything. And you say, well, hey, but this says we have to add to a multiple of another equation. Okay, fine. Then to justify that, or to satisfy that, we multiply all this by just 1, which does nothing, but it's a multiple of it. So all we're doing now is we're just going to add the first row to the second row. Just simply adding straight down. So x plus -x just gives us 0. Great. 2y plus y gives us 3y. I'm sorry, I don't have to write a positive. -4z minus z gives us -5z. And then last, 8 plus 10 gives us 18. So we go back and look at B, and B says rewrite so that the leading coefficient in the second and third equations are 0. So what do we have here? We have, this is 0x, 0x, exactly what we wanted. So we have done exactly what it's asked. Now, what I want to do is, I keep using this row, all right, and I probably should have used equation here, and equation, and equation, and equation, and equation, but what I'm getting at is we're going to basically kind of stop writing them as equations. And we're going to rewrite them what we call an array. An array is just a string of numbers. So what it looks like is we're going to do this. Rewrite a system as an array. And how you do that is you only use coefficients. So if I have this system, 3x plus 6y minus 12z equal to 12, I have x minus 2y plus 5z equal to 7. And then lastly, I have negative x plus y minus z equal to 10. I want to rewrite that, all of that, as an array. So I'm using only the coefficients. So here's what it's going to look like. I have a 3, positive 6, negative 6, and then I have a 12. So I have 3, 6, negative 12, positive 12. And I keep going. Next row. 1, negative 2, positive 5, 7. 1, negative 2, positive 5, and 7. And I'm just going to write the last row. So what you have now is you have it written as an array. Now you say, okay, well, the positive and negatives is there, but what about the equal signs? How you justify the equal signs right here? You put just a vertical line that separates one side of the equation from the other. Now, what this is called a matrix, and we're trying to solve these matrices a certain way. And our goal is when we solve these, because next we're going to solve it, our goal is to get our matrix to look something like this. Our goal is to get our matrix to look like a leading coefficient, then zeros below it. The next row, the next variable would have a leading coefficient of 1, and then zeros above and below it. Then the very last one, so forth, you can see the pattern. And then this over here is just some number. We don't really care what these numbers are because these are our solutions. We care in our solution, but they don't have to be anything specific. Now, one thing that I forgot to say is if you notice, going back to our equations here, this column represents our x values. The next column represents our y values, and the next column represents our z values. And you can see that clearly, that negative 12, 5, and negative 1 show over here, negative 12, 5, and negative 1, right there. All right, so let's move to our second example here. So we're going to solve using Gauss-Jordan elimination. It does not have to be 3 equations, 3 variables, right? I said at least 2 equations and at least 2 variables. So that's what we're going to start with, and we're going to show you how. So first thing you need to do is write it as a matrix, write it as an array of numbers. So we're going to rewrite it as 2, negative 6, negative 8, negative 5, 13, and 1. It's very important that you make sure you space out your values enough so you know where the separation is. So notice how I have enough separation here that you know that these numbers are all separate, okay, against each other. So next we have to remember, we go back to our goal. Our goal right now, this would be like our goal would be to look something like this. because we have what we call a 2x2 matrix, which we'll get into later in the chapter. But our goal is that our matrix will look something like this. So the first thing we do is we try to find and make this 1. And so we're used to that already. We just did it. And what we're going to do is we're going to say we're going to multiply the first row by the reciprocal of this coefficient, which is 2. So we're going to multiply by the reciprocal, which is 1/2. So that means that it's going to look like this. And you'll see it's going to change the notation a little bit. And we're going to multiply the first row by 1/2. So we're going to say 1/2 times row 1. So R is row, and the subscript tells you what row it is in. Now, we are not changing the second equation yet, so we're just going to leave it. Even though you might want to say, oh, hey, I need that to be 1, so let's go ahead and make that a 1. You do not do that yet. Hold off on that. So we're not changing the bottom. So I'm just going to rewrite the bottom. Now I take 1/2, multiply it by 2, and I get 1, which was our goal. And then 1/2 times -6, which is -3. And lastly, 1/2 times -8 is -4. So first step, done. We want this to be a leading 1. The next thing you want to do is to make all of the other values in that column 0. On the next section, we talk about what this is really called. So we're going to make that a 0. Remember, in order to make that a 0, we can't just multiply by 0. We have to multiply by another equation and add it to it. So we are, in this here, we are going to multiply the first row by 5. We're going to say 5 times row 1, then we're going to add that to row 2. Now notice how I've written this as what I am not changing and what I am changing at the end. That's how I'd like you to write it, is whatever row you are changing, I want that to be the last thing that you write in your operation. And I don't want to keep moving to the right, so we're just going to come down here. And I'm not changing my first row at all. So 1, -3, and -4. That's not changing. Now I'm multiplying this by 5, so this is 5 now. 5 minus 5 is 0, which is exactly what we wanted. Multiplying this by 5, so this is really -15 now. And when I take -15 and add it to 13, I get -2. Multiplying this by 5, so I get -20, so this is -20 plus 1, which gives me -19. And from there, I've done what I wanted to. I wanted this to be 0 below the leading coefficient of 1. Next, I go to my next equation, and I want that next leading value to be 1. So that means I'm trying to get this to be 1. In order to do that, I'm going to multiply by the opposite, which is -1/2. Sorry, not the opposite, the reciprocal. Use the wrong term up. That's my fault. So it's by the reciprocal, which is -1/2. So -1/2 times row 2. I am not changing row 1, so I'm going to rewrite it. Now I'll multiply everything by -1/2 on the bottom. So this is 0. -1/2 times -2 does give me a +1. And then -1/2 times -19 gives me a +19/2. And I see a fraction and start, okay, what am I going to do here? We are going to have to work with fractions. And that's something we need to be comfortable with. So the next thing is now that we have the leading coefficient to be 1, now we want all the other values in that column to be 0, which means that I need to make this 0. So I need to multiply this number by a value to make that 0. So I want to multiply by the opposite. So we're going to multiply the second row by positive 3. So 3 times row 2 plus row 1. This one, I am not changing that bottom row. So 0 times 3 is 0, plus this 1 here is just 1. And then now I have 3 times 1 is 3. And then I basically have 3 plus negative 3, which is 0, which was our goal. And now I have 3 times 19 over 2, which I'll write that in scratch work. This is 3 times 19 over 2, which gives us 57 over 2. We still need to add that to negative 4. So we have to rewrite negative 4 as a fraction over 2. So we're going to write that as 8 over 2, because 8 over 2 is 4, and I have the negative. So now we have 57 minus 8, and that gives us 49 over 2. So what does this tell us? Remember, this column is our x, this column is our y. This tells us that x equals 49 over 2, and our y value is 19 over 2. These are the values that will satisfy both equations at the exact same time for them to equal each other. All right, so that was a very simple explanation, nothing crazy. It was an easy 2 equations with 2 variables. But what happens when you have 3 equations with 3 variables? Okay, so I am going to write that for you, and what I want you to do is while you're doing this, or while we're doing this, I'm going to stop at some point and have you finish. So example 3, and then you can of course pause it and come back and check it. Example 3 says solve using Gauss-Jordan elimination. So here's our system. 3x minus 6y plus 9z equal to 0. 4x minus 6y plus 8z equal to negative 4. And then negative 2x minus y plus z equal to 7. First thing we need to do is write it as a matrix, so write it as an array of numbers. So 3, negative 6, 9, 0. 4, negative 6, 8, negative 4, negative 2, negative 1, 1, and 7. So what I want you to do, your very first step, and I'm going to have you pause this, and all of a sudden I'm just going to come back and the answer is going to be there. I want you to make this become a 1. That's all I want you to do. Then, after you make that to become a 1, then I want you to make this become a 0 and that to become a 0. All right, so I'm going to pause this here. I'm going to stop it. I want you to pause it, and then I want you to do the work and then come back and you'll see the answer here. So go ahead and pause right now. This is what you should come up with. All right, the very first thing is you multiply the first row by 1/3. Once you multiply by 1/3, then you get the leading coefficient. In order to make d 0, you multiply the top equation, the first row, by -4, add to the second to make that go to 0. Then you take the first row, multiply it by a +2, and then add those two together to make that become 0. All right, I'm going to have you pause it again. What I want you to do next is I want you to make this leading coefficient of the second equation to become 1. And then after you do that, then make everything else in that row to become 0. So I'm going to pause now. I'm going to stop the recording now, and I want you to go ahead and pause. All right, check your work. So the first thing we're going to do is we multiply the second row by 1/2 to make this become a 1. Once we have that, in order to make this become a 0, we multiply the second row by 2, add it to row 1. That becomes a 0. And then the last step here is to multiply this by 5, add it to here, and to get that to become a 0. All right, so last step, last goal here is to make this become a 1. And once you make that to become a 1, then make everything else in that row to become a 0. So I'm going to stop it here. I want you to pause, try it, and come back. So go ahead and stop now. All right, so check your work. In order to get this leading coefficient down here to be 1, I multiply the whole row by -1/3. That gives me this here. In order to get these to be 0, to take care of the first row here, multiply this by nothing, really just by 1. So I shouldn't say nothing, multiply it by 1. I'm just basically adding row 3 to row 1. And you can see these zeros don't affect anything because what's 0 plus 1? It's just 1. 0 plus 0 is just 0. That's why it's important to make the leading coefficients 1 and then everything else in that column to be 0. Next, after we do this, then we multiply this row by 2. And then when you add those two together, you get 0. Multiply this by 2 and add those two together, you also get 0. That's where we're at there. Now, what does this tell us? This tells us our answer. This tells us that, remember, this is our X column. This is our Y column. This is our Z column. So this tells us that X is -3, Y is 0, and Z is 1. There is our answer. All right, so I told you that I would show you the interchanging of rows at the end of our lessons. That's what we're going to do really quickly at this little bottom here. So what if, play the what if game. What if we're given this? Y plus Z equal to 0, and we have 3x minus y plus z equal to 6, and we have 6x minus z equal to 3. So let's go ahead and put this in an array. So let's write this in a matrix. Our matrix shows 0, 3, and 6, 1, -1, 0, 1, 1, -1, and then 0, 6, and 3. Now, if we go to do this, we try to get a leading coefficient of 1. So how in the world can we get a leading coefficient of 1 when all we can do is multiply or add to something else? So instead of multiplying by this and then adding to here, or multiplying by here, adding to there, we're just going to simply interchange the rows. We can move the whole equation or the whole row, but the whole thing has to go with it. So what I'm going to do is I am going to just interchange row 1 with row 2. So now I just write row 2 at the top. 3, -1, 1, and 6. Then now row 1, which was here, that now becomes row 2. 0, 1, 1, 0. And then row 3, we did not change. Now I can go and make my leading coefficient 1. Now, does it matter which rows you interchange? Absolutely not. But I would suggest that one because when I do this, then I know that I already have a leading coefficient of 1. That's one less step to do. All right, and that is the end of our section.